Paleontology is the science of reading messages from the dead. It's forensic investigation conducted on a timescale most human minds can't hold, and the fossil record is its evidence locker. Every fossil you've ever seen is a crime scene millions of years old. The victim is a creature that no longer exists. The cause of death is almost always lost. The witnesses are gone. And yet, from the bones, the shells, the footprints, the carbon stains, the polished stomach stones, paleontologists have reconstructed 3.5 billion years of life on this planet. Every continent that has ever existed, every ocean that has ever drained, every mass extinction, every evolutionary leap. They've done this from a sample size that should make the entire project impossible. Less than 5% of the species we know about today have left any fossil at all. Less than 1% of every species that has ever lived has been preserved. The library of past life is mostly empty shelves. This video is the foundation. It's the answer to one question. What is a fossil, really? And how does the fossil record actually work? In the next few minutes, we'll walk through what counts as a fossil and what doesn't, how preservation actually happens, the 5 major ways a once living creature gets locked into stone, and the rare conditions that allow it, what paleontologists can read from each kind of evidence, and what stays forever beyond reach. Why some species, like trilobites, leave thousands of traces, while others, like Tyrannosaurus rex, leave so few that every individual specimen has a name. And what Charles Darwin meant when he said the fossil record is like a book, with most of the volumes missing and chapters torn from the rest. Welcome to Stoneform. This is Paleontology 101, but not the version you got in school. It's the case file, the evidence kit, and the methodology behind one of the most ambitious cold case investigations in human history. Because once you understand what a fossil actually is, every weird, beautiful, controversial, billion-year-old object that comes out of the ground starts making sense. Start with what a fossil actually is and what it isn't. The popular picture is wrong in a useful way. Most people imagine a fossil as a bone turned to stone. That happens. It's one of the oldest and most common forms of preservation. But it isn't the whole picture, and treating it as the whole picture is the first mistake every beginner makes. A fossil is any preserved evidence of past life held in a geological context. That's the working definition paleontologists use, and every word in it is doing work. Preserved, meaning the original organism, or some trace of its existence, has survived deep time. Evidence, meaning a fossil doesn't have to be a body. It can be a footprint, a burrow, a patch of mineral residue where soft tissue used to be. Even, in some cases, fossilized excrement, called a coprolite, from the Greek word kopros, meaning dung. Past life, meaning the organism is no longer with us and isn't part of any living lineage we can sample directly. Geological context, meaning the evidence is locked into the earth in sedimentary rock layers we can date, typically using radiometric methods like potassium-argon or uranium-lead dating of the surrounding rock. Radiocarbon dating works for specimens younger than around 50,000 years, but for anything deeper in the record, it's the chemistry of the rock itself that gives us the age. Here's the staggering part. Becoming a fossil is one of the rarest things that can happen to a once living thing. The number is hard to pin down exactly, but most paleontologists put the odds at less than 1/1000th of 1%. For every organism that ever lived, walked, swam, flew, or photosynthesized on this planet, the overwhelming default is that nothing was preserved. Not a tooth, not a bone fragment, not even a shadow. The reason is that the Earth is built to erase. When something dies, The first thing that happens is decomposition. Bacteria, fungi, scavengers, weather, all working in parallel to break the body down to nothing. The second thing that happens is geological motion. Rivers wash bones away. Glaciers grind them. Heat and pressure inside the crust cook them out of existence. To become a fossil, a creature has to dodge every one of those forces. It has to die in roughly the right place. It has to be buried fast enough that decomposition can't finish its work. It has to be sealed in sediment with the right chemistry, often in low oxygen water where bacteria can't thrive. It has to stay buried, undisturbed, for thousands or millions of years. And then, only then, it has to come back to the surface in a form a human being can recognize at a time when a human being is around to find it. Most of whatever lived will never be recovered. The fossil record is what slipped through the cracks. The detectives are working with a tiny, biased, miraculous sample of every party that ever happened on this planet. The job, as we'll see, is to read it anyway. The evidence comes in 5 major categories. Each one preserves something different. Each one tells the detective a different kind of story, and each one requires a different set of conditions to form, which is part of why the fossil record is so uneven. Entire kinds of life are visible only through 1 or 2 of these methods, and invisible through all the others. The first and most famous is permineralization, which is the process most people picture when they hear the word fossil. Mineral-rich groundwater seeps into a buried bone or piece of wood. The water carries dissolved silica, calcium carbonate or pyrite. Over thousands of years, those minerals fill every microscopic pore and, in some cases, replace the original organic material entirely, atom by atom. What you end up with is a stone replica, faithful down to the cellular structure of the original. Petrified wood is permineralized. Most dinosaur bones you've seen in a museum are permineralized. The Latin word petra means rock, and facere means to make. Petrification is literally the process of being made into rock. Paleontologists prefer the more precise terms permineralization and replacement because they describe the chemistry instead of the result, and because, here's the misconception again, many fossils aren't petrified at all. The second category is molds and casts. Imagine pressing a shell into wet clay and pulling it out. The impression left behind is a mold. If, over time, sediment fills that impression and hardens, you get a cast, a 3-dimensional replica of the original object made of completely different material. Most ammonite fossils are molds and casts. So are many fossil leaves and footprints. The original organism is long gone, but its shape, its surface texture, and sometimes its motion through the world are preserved in negative space. The third is carbonization, also called compression. When an organism is buried under enough sediment, the heat and pressure cook out everything except a thin film of carbon. What's left is a black silhouette of the original creature, almost like a shadow burnt into rock. Carbonization is how most plant fossils survive. It's also how some of the most exquisite fossil fish, insects, and even early feathered dinosaurs have come down to us, with anatomical detail visible to the naked eye. The fourth is actual preservation, which is the rarest and the strangest. Sometimes, by accident, the original organism survives largely intact, frozen in ice, wrapped in tree resin that hardened into amber, or sealed in natural asphalt. Mammoths have come out of Siberian permafrost with hair, skin and stomach contents still in place. Insects from 100 million years ago sit in amber as if they were trapped yesterday. These sites and deposits, places where exceptional preservation has produced an unusual abundance of detailed fossils, are called Lagerstätten, a German term meaning storage places. The Burgess Shale in British Columbia and the Chengjiang Biota in China are two of the most famous. Both captured soft-bodied Cambrian life that would otherwise have vanished without a trace, giving us our clearest windows into the explosion of animal body plans over 500 million years ago. Lagerstätten are the fossil equivalent of a locked crime scene, sealed before the evidence could be disturbed. They aren't common, but they're scientifically priceless because they preserve the soft tissues that almost every other type of fossilization erases. And the fifth is trace fossils, which contain no body at all. A trace fossil is a record of behavior, a footprint sequence frozen in mud, a burrow tunneled through an ancient seafloor, a nest, a tooth mark on bone, a polished gastrolith, a stone a sauropod swallowed and used to grind its food, sometimes carried hundreds of kilometers from its origin. Coprolites, fossil dung, are trace fossils too, and they tell us what extinct animals ate, sometimes down to the species. A trace fossil doesn't show you the animal, it shows you what the animal did. For a forensic investigator, that's often more valuable. 5 categories of evidence, 5 different witnesses. The next question is what you can actually do with them. The detective work has a name. It's called taphonomy, and it's the branch of paleontology that asks not what an organism was, but what happened to it after it died. Taphonomy is, almost word for word, forensic science applied to deep time. It studies the moment of death, the conditions of burial, the chemistry of the surrounding rock, the position of the body, the marks left by other animals, the pressures and temperatures the remains experienced over millions of years. From all of this, taphonomists work backwards to reconstruct what the original creature looked like in life, what it ate, what killed it, and what its world was like. Some of those reconstructions are easy. Trilobites, the armored marine arthropods that ruled the oceans for 270 million years, from the Cambrian through to the end of the Permian, left behind so many fossils that a single beach in Morocco can yield thousands of specimens. Over 21,000 trilobite species have been formally described. Trilobites had tough, mineralized exoskeletons. They lived in shallow seas where sediment was being laid down constantly. They existed in vast numbers, almost every box checked. Their fossil record is thick. We know more about trilobite anatomy, behavior, and evolution than we know about most living animals. Other reconstructions are nearly impossible. Tyrannosaurus rex is the most famous animal in human history, and yet, after a century and a half of paleontology, we have only around 50 to 60 reasonably complete specimens. Every one has a name: Sue, Stan, Scotty, Trix. Most of them came out of the Hell Creek Formation, a band of late Cretaceous rock running through Montana, the Dakotas, and Wyoming, one of the few places on Earth where the right rocks from the right time period are exposed and accessible. The reason so few specimens exist is that T-Rex was large, which makes burial harder. It lived on land, where decomposition runs faster, and as an apex predator, there were never very many of them to begin with. The detective gets very few crime scenes to work with, and every one of them is precious. This is the bias built into the entire fossil record. Hard-bodied creatures with shells and exoskeletons dominated. Marine animals dominated. Big populations dominated. Soft-bodied life, jellyfish, worms, fungi, microbes, the actual majority of life on Earth at almost every point in its history barely shows up at all. Entire ecosystems are missing. Entire continents and time periods are underrepresented because their rocks have been eroded, subducted, or simply never explored. Charles Darwin saw this clearly. In On the Origin of Species, published in 1859, He compared the fossil record to a single book preserving the history of life, except that most of the volumes are missing. The pages of the surviving volumes are torn, and only a few words remain on each page. That's still the best metaphor anyone has produced. Less than 5% of the species we know about today have any fossil record at all. Less than 1% of every species that has ever lived has been preserved. The book is mostly empty. But here's the trick. We've read it anyway. 3.5 billion years of life on Earth, mapped out in ages and ecosystems, Cambrian seas, Jurassic forests, Cretaceous killing fields, all reconstructed from the torn pages. The detectives are good at their job. The next question is why any of this matters. Why does any of this matter? Why bother reconstructing crime scenes from creatures no one will ever meet, in worlds no one will ever visit? The honest answer is that the fossil record is the only memory the planet has of itself. Without fossils, we wouldn't know that the world is old. We wouldn't know that life evolves, that species rise and fall, that mass extinctions have happened 5 times before, that the rocks beneath your feet were once a tropical sea, that birds are the surviving lineage of dinosaurs, that humans are roughly 200,000 years old in a story that stretches back 3.5 billion. Every one of those facts is reconstructed from torn pages. None of it is obvious. All of it is real. The other answer is that the fossil record is wildly stranger than people realize. Once you understand what a fossil is and what it isn't, you start running into the cases that broke the textbook. The town in Australia where dinosaur bones come out of the ground as opal, actual rainbow gemstones formed where the bone used to be. The German pit, the Solnhofen limestone, one of the great Lagerstätten of the Jurassic, where a 50-million-year-old beetle still carries the iridescent color of its wing case, preserved exactly as it lived. The 1,000-year-old practice of grinding up dinosaur fossils and selling them as dragon bones in traditional medicine, which destroyed entire specimens before scientists realized what was being eaten. The 2 American paleontologists who sabotaged each other's dig sites, dynamited fossil beds, and bribed witnesses in a feud known as the Bone Wars. The auctions where individual T-Rex specimens have sold for more than $30 million, outperforming the S&P 500. None of that makes sense without the foundation. With it, every story snaps into place. That's what this channel is going to do. Stoneform exists to take the strangest, the most beautiful, the most controversial, and the most overlooked stories from the fossil record and walk through them properly, in the same forensic spirit as the science itself. Because once you see paleontology the way paleontologists actually see it, as the ongoing investigation of a planet's deep past told through fragments most people would mistake for ordinary rocks, you can't go back. Every cliff face becomes a case file. Every museum becomes a crime scene reconstruction. Every plain, grey stone in a riverbed might be a witness that has been waiting hundreds of millions of years to talk. The library of past life is mostly empty shelves, but the books that survived contain stories no one has finished telling. The work of paleontology is to find them, read them, and bring them back into the light. Welcome to the case file. The investigation continues.